Hey, it's been a while since I've made a little video like this, but today the topic is going to be teaching how to do exponential growth calculations and projections, extrapolations of the of these curves. And what we're looking at today is the pandemic that we're all a part of, the coronavirus. And today, with being March 25th, I thought this is a good learning opportunity. One of the things that always is interesting to me is trying to make predictions of what might happen. And as we see on the screen here, the Johns Hopkins University dashboard for coronavirus is showing us in the upper left-hand corner, we have 438,000 confirmed cases worldwide. Of course, the map shows us the distribution of those confirmed cases. We see the total number of deaths and total number of recovered patients. And down in the lower right corner, we can see the exponential growth curve. This is worldwide with 172 regions in effect. This dashboard is a very nice dashboard. And so what I did starting, I don't know, maybe a week ago, is capturing this dashboard in a series of screenshots. So every day or maybe twice a day, I might go in and capture the data. And what this is then, by doing that, is you capture the picture, the essence of what each country, where each country stands. You can take a look at the totals. You can see this punctuated growth from here to here to here to here. And you can get a picture and record that picture for posterity. And so when you do that, it looks like this. So here's back on March 12th. So that's been, well, almost 2 weeks now. We were at 128,000 cases. And as I scan through these captured images, you can see how the situation is changing. If you look at the lower right corner, you can see the continued growth of the exponential, the growth of number of confirmed cases. And pretty soon we're up to where I want to get with the actual data then. So let's take a look at how you use this information. What I've done in essence is just basically capture the data and just type it into a spreadsheet. So if I blow this up a little bit, we can have a look at it. And so I've captured 26 discrete points in time. And you can see I've typed in the date and time, the number of confirmed cases, the deaths and recovered cases. And then I've spawned off from that a number of metrics. So we can compute the number of hours in between readings, and then the change in the number of countries impacted, or the number of regions, confirmed cases, death cases, and recovered cases. And we can see, for example, that when you normalize that in terms of the change per hour, the number of confirmed cases per hour, deaths per hour, and recovered cases per hour. So this then leads me to really the whole topic of the conversation is I'm curious to know, as the situation changes, if I pick any point in time to calculate the exponential growth, what would it look like? So for example, the first calculation we'll look at is here on line 20, that after 19 discrete captures of this information, I wanted to know when would the 1/millionth confirmed case occur. So I'm going to show you how that's done here. But so using data through the 20th, that was basically 8 or 9 days of data. I projected the millionth case being on April 4th at 2100 hours. Well, yesterday I did a second projection. 4 days later, the number of cases went from 272 up to 409. So of course, the closer you get to the millionth case, the more accurate you're going to be. And we can see that the time required, the projected time for the millionth case is now April 3rd at 2 in the afternoon. So as this red number, as I do these projections, this number is going to converge on the millionth case as we approach the millionth case. But we can see that it's actually going down, it's becoming sooner, which means that the exponential growth is still growing, and that's not a good sign. So how do I actually compute the predicted millionth case. Well, it's fairly easy to do. If you just take your data, you have this is shown in blue are the actual data points through the 20th that I'm using. And so you take the days, you just basically drop in the date, and then you compute the number of days. It's just a formula. Take this one, subtract it from that one. And so you do this relative to your beginning point. So this is an accumulation of days of data. And then you have your confirmed cases. So this is your actual data. And then we're going to go into the predicted data. So what I did for that was I'm making predictions every quarter of a day, or in other words, every 6 hours. So I just start a formula at the end of the last known data point, add a quarter day to it, and then that spans out, and I go down far enough to be able to pick up what's going to be the millionth predicted case. So with that, then you have your initial time, then your futuristic time, your initial known data, and then we want to get to the predicted data. So how do you get to the predicted data? Well, it's a pretty simple formula. You basically just say, you take the growth formula with basically 4 parameters. The first parameter is, or let's go ahead and type in here to see what happens. The first parameter set is your known Y cases. So that's this blue box here, the number of confirmed cases. The second parameter set is your known time, and that's shown in pink here. And you notice that those are anchored in terms of absolute references. The third parameter set is the predicted times in the future that you want to make the prediction. And the fourth parameter is either a 1 or a 0. In this case, it's a 1. And this allows the calculation of that exponential growth. And as we look down then through here, we can see that the millionth case occurs between 4:4 at 2100 hours and 4:5 at 3 o'clock in the morning. If you want to look at what does that look like, of course, you could plot this in Tableau or Excel here, as we see, and that's basically what I've done, is just shown here's the measured data. You could see the chaotic nature of it because it's not, I just punctuated periodically, picked these data points, and then here's the predicted data, the exponential growth. So that's how you do it. Fairly easy to do. And so here's the prediction on 320, then here's the prediction on the next case of 324, and the millionth case comes up on April 3rd. So that's it for now, and I think I'll eventually write this up into a post, but for now that's kind of a little running experiment to help with keeping practice on how to do exponential growth calculations.